In this video, we'll take a look at graphs of logarithmic functions. So the first thing we want to take a look at is the relationship between logarithmic functions and exponential functions. So if you remember from the previous chapter, if you want to graph the function y is equal to 3 to the power of x, if we plot a few points, x, y, when x is negative 2, y is equal to 3 to the power of negative 2, which is 1/9. Negative 1, we get y 3 to the negative 1, which is 1/3. 0, 3 to the power of 0 is equal to 1. 3 to the power of 1 is 3. And 3 squared is 9. So we could plot these points and we would have a nice smooth curve for our graph of y is equal to 3 to the x. Now let me go ahead and do that. So our exponential function, negative 2 is 1/9, negative 1 is 1/3, 0, 1, 1, 3. So if you remember, this won't cross the x-axis. This is the function 3 to the x. So characteristics of our function, y equals 3 to the x. Characteristics of exponential functions in general. The domain is all real numbers. The range is 0 to infinity. That makes a horizontal asymptote at y is equal to 0. The y-intercept is 0, 1. Our function is increasing if b is greater than 1. This is 3 to the power of x, so our function is increasing. And our function is decreasing if b is between 0 and 1. So if our function were 1/3 to the power of x, our function would be exponential decay. So how is this related to the logarithmic function? And notice that these are a one-to-one function. Exponential functions are one-to-one. For every x there's a y, and every y there's only one x. So if we take y equals 3 to the x and find the inverse of that, remember the inverse is interchanging x and y. X is equal to 3 to the power of y. Then solve for y. In this case, we can't solve for y, but we can rewrite it in logarithmic form. So we end up with y is equal to log base 3 of x, or our function g of x log base 3 of x is the inverse of y equals 3 to the x. So when you look at the sets of points and the values, the x and y coordinates are reversed. So when x is 1/9, y is negative 2. When x is 1/3, y is negative 1. When x is 0, y is 1. 3, 1, 9, 2. So we interchange x and y. What does that mean with the graph? Well, now we get 1/3 negative 1, 0, 1, or 1, 0. Sorry about that. There we go. 1, 0, 3, 1. And when we connect, notice that these two graphs definitely are reflections of each other over the line y equals x. They are inverses of each other. So in the inverse section, that means that characteristics of logarithmic functions are the inverse of the characteristics of exponential functions. So that means if the domain was negative infinity to infinity of exponential, that's going to be the range of the logarithm. The range was 0 to infinity, so that's now going to be the domain. And if you take a look at the graph, you can see the vertical asymptote instead of horizontal is now x equals 0. The x-intercept is 1, 0. It was the y-intercept in the other. A key point, so we'll talk about key points, is when you let the key point in the logarithm is 3, 1. Or B1 is the key point. These go down here. Your logarithmic function is still increasing if b is greater than 1, and it will be decreasing if b is between 0 and 1. So exponential and logarithmic functions are inverses of each other. So what we can do, now that we know that, we can find the domain. So that's, and the vertical asymptote if we have the equation. So the domain, we know that we can't take the log of a negative number. So to find the domain, take whatever you're taking the log of, log base 4 of x minus 5, and set x minus 5 greater than 0, because we have to take the log of a number that's 0 or greater. So in this case, the domain is x is greater than 5. So that would be the values from 5 to infinity. Finding the vertical asymptote means which way is your function moving? So log base 4, think of transformations of x minus 5 moves log base 4 to the right 5. So if we move to the right 5, everything moves to the right 5. So our new vertical asymptote is going to be x is equal to 5 because our graph moved to the right 5. So let's take a look at another example. So transformations, graphing with transformations. We're going to graph the function log base 4 of 5 minus x. So to analyze the equation, we know the function that's being transformed is log base 4 of x, which is also the inverse of the function 4 to the power of x, since exponential and logarithmic functions are inverses of each other. Rewrite the function f of x so we can tell what the transformations are. So if you switch x in the 5 minus x and rewrite it as negative x plus 5, and then factor out a negative, you can tell that we're going to have a reflection of some sort, and then we have to factor out the negative because we're adding or subtracting something to x. Up here, we're adding 5, but we're adding 5 to the negative x. That's why we factor out a negative. We're actually subtracting 5 from the x coordinate. So this tells us that we're going to take the graph of log base 4 of x. We're going to reflect it over the y-axis because of the negative value on x, and then translate 5 units to the right because we're subtracting 5 from the x value. So graph g of x, and we're going to call g of x the log base 4 of x, okay? And the graph log base 4 of 5 minus x to check and make sure you're right. And then we're going to graph that in Desmos and create a table of values. So when that's graphed in Desmos, make that a little bit bigger, you type in g of x is log base 4 of x, so that's this function in the black ink. Then type in f of x equals log base 4 of 5 minus x, that's the graph in the red ink, and plot some points. You'll notice that the horizontal asymptote is x equals 0 for the original, but when we move it to the right, reflect it, and then move it to the right 5, or the new vertical asymptote is at x equals 5. Then we want to identify, when you graph these in Lumen, you have to identify 2 points. So that's why I have you have a table of values. When x is equal to 1, f of x is equal to 1. So one of the points on your coordinate that is 1, 1. Then another coordinate, when x is 4, y is 0. So 4, 0 is another point, an integer point. And that's what Lumen wants. It wants to know the vertical asymptote and 2 integer points that are within the window on the graph. So when you're in Lumen and you have to graph, notice you have to graph the vertical asymptote first. So you select vertical asymptote, click on 5, and it will draw that in. And then you click on the point 4, 0, and click on the point 1, 1, and then it will graph your function. All right, so you try it. Graph f of x is equal to log base 2 of 3 minus x. The first thing we do is describe how the function g of x equals log base 2x is being transformed. So again, we want to rewrite this log base 2. We're going to switch x and 3 and factor out a negative. So if we rewrite our function so that we can tell what the transformations are, we're again reflecting over y. And then the function is moving to the right 3. Then graph your two functions using Desmos and create a table of values so you can see what happens. So we're going to graph log base 2 g of x equals log base, let's see if I can find the function. So the function is log base 2. Go to miscellaneous functions. There's log base a. So it's log base 2 of x. And then I want to take that L out of there. And then our function f of x was equal to, grab that miscellaneous function, log base 2 of 3 minus x. So you can see how the two functions are related to each other. So we've got our g of x, which is log base 2 of x, and f of x, log base 2 of 3 minus x. Now let's make a table of values using Desmos so you can see. So add a table. Putting it in function notation is what will allow you to create the table pretty quick, and I'm just going to put f of x in here. So if I put in -2, -1, 0, so that gives me an integer point, 1, 2. So I have an integer point at -1, 2, an integer point at 1, 1, an integer point at 2, 0. So you could use any of those 2 points to create your graph. So our vertical asymptote now is going to be at x equals 3. And integer points identified so that you can graph it in Lumen are, you could use any of the ones that you prefer. I'll go with -1, 2, and 1, 1.